This is Mark Anderson for Kellogg Community College, covering Math 121 Intermediate Algebra, Chapter 2, Section 2, Functions. Now, we're going to take a look at some functions and talk about the domain and the range. The domain, forgot to turn on my pencil here. The domain are going to be all of the x values in that function, and the range is going to be all of the y values. More importantly, if you have trouble remembering what domain and range is, x or y, think of alphabetical order. Domain comes before range in the alphabet, and x comes before y. And that will help you a little bit. Now, the definition of the function is that a function is a correspondence between a first set and a second set, such that each member of the first set corresponds to exactly one member of the second set. So, a function is a correspondence between the domain and range, such that each member of the domain corresponds to exactly one member of the range. Or, for every value of x, there's one value of y. No more than one value of y, or else it would break that function test. Now, let's do some examples from real life. Think about a model of an automobile, and then the correspondence would be the company who made it, and then their parent manufacturer. So, for example, you might think of the Focus. And I know this is probably a proper noun, so we're going to put capital letters there. All right, so it's the Focus. What? It's the Focus, and who makes that? Ford does. So the Ford Focus. So the Focus has one parent manufacturer, and we're not going to get too specific here. We're not going to say, well, it's possible it has some other car manufactured parts in it. When you think of the Focus, you think it comes from Ford. And we can come up with lots of different car manufacturers here, like we'll say Forester, and that would be Subaru. But what you'll see here is that these cars have only one manufacturer to go with it right there, even though there is a legacy. The legacy goes to Subaru, and it says for every one of the domain, it links to only one on the range. Now, where this breaks down, because this is definitely a function, for every value of x, there is one value of y. What would happen to break this idea of being a function is if we think of some soda companies, you know, like Coke and Pepsi. And you'll notice it says what kind of diet soda they make, and you'll notice that Coke makes more than one kind of diet soda. It makes actually a Diet Coke, and technically Coke Zero is considered diet, and therefore this does not follow the rule of a function. See, it says for every x there should be at one value of y. Well, here's a value of x and it has two values of y. It already fails the function test. Even if Pepsi only made one diet soft drink, which we know it does, you'll notice that there's other kinds of diet Pepsi that have come out very recently, and so since we can list other y values for this one x, this does not fit the function. So in the real world, this is not a function. And we can even go back to the car problem here, and if we made Ford or Subaru the domain, then this would fail to be a function because they make many different cars as the range. So let's go to some numerical values here. Let's go to some real numbers here. The real numbers, the domain real numbers are numbers from negative infinity to positive infinity, rationals, irrationals. It doesn't include imaginary numbers and numbers that like dividing by zero. But so real numbers are really what we can kind of come up with and use. And the correspondence is the square of each number, and the range is their shared values. Well, this is going to be pretty straightforward, because if you come up with just the domain of just some real numbers, and we'll pick some nice integers just so they're easy. So -2, 1, -1, 0, 1, and 2, and we're going to map their squared numbers. -2 squared is +4. and there's the mapping there. Negative 1 squared is positive 1. 0 squared is 0. 1 squared is positive 1, and so there, that mapping, notice that this doesn't go to more than one answer, and 2 squared is 4, so you can see that this is still okay. It's still a function. It's just that right now it has more than one going to that. And we can actually plot this on the graph too here. Negative 2 on my x goes to 4, like that. Negative 1 goes to 1, like this. 1 goes to 0 goes to 0, so that's pretty easy. 1 goes to 1, and 2 goes to 4. So this is a function, and this function is actually given by the equation y equals x squared, but this is an example of why this is called a function. So this actually works. This does not work though. This is called the square root of, if we pick real numbers again, and we pick the square root of each of those numbers, we're going to list out their rooted values. So let's pick some numbers that have some pretty easy square roots. So let's pick 9, and we'll pick 4, and we'll pick 1. Now if we pick 9, you'll notice that the square root of 9 is 3. But that's not the only answer. The square root of 9 is technically negative 3 as well, because the square root is the positive and negative of any number. So because negative 3 times negative 3 makes 9, and so does 3 times 3. So this is automatically breaking the function rule because the domain has more than one on its range. And the same thing goes with 4. 4 has 2 answers here. 4 has 2 and negative 2, and 1 has 1 and negative 1. So if I had to graph that, what that would look like if I picked, let's say I picked 9 on my x, and what's going to have to happen here is on my grid here I'm going to have to go to, let's say, 2, 4, 6, 8, 10. Let's just see if that's 10. So 9 on my x would be positive 3 and technically negative 3. 4 on my x, if this is 2, 4, this would be 4 right there. 4 on my x, this would be positive 2 and negative 2. And we're going to go to 1 on my x here. 1, which is about right there. 1 is going to be 1 here and 1 here. So you'll see that this is a graph, but it's actually not a function. This fails because for every 1 on my domain, I happen to have 2 on my range, except for that value of 0 there. So this fails the function test, where this here passes the function test. So another picture of, like, as it says, draw a picture of 2 graphs that can pass as functions and 2 do not. This doesn't pass as a function. Even a wavy line, like a straight line, would pass as a function, but even a wavy line, something that was maybe disconnected and reconnected, in a different place, this is still considered a function. Whereas something that doubles back on itself, like this, is technically not a function. So this is a function, and one of the visual tests for figuring out if these are functions or not is something called the vertical line test, or the VLT. And I'm going to move these down a little bit and redraw these graphs, because the vertical line test is a quick visual way, if you look at a graph, to see if it's an actual function or not. So this is a function, and I'm going to redraw another graph here. Let's say it's open here, closed up here. It can stop. It can start at a new location. These are functions, and the reason why they function is because the vertical line test is if you can put a vertical line through a function and it only intersects the line in one place, then it's technically a function. Looking at this right here, this is a function because if you put the vertical line there, it only touches in one place. Now you might say, well, what about here though? Doesn't it touch in 2 places? Well, no, because since this is an open circle, there's technically nothing here, so this vertical line test still works. Vertical line test, well, it doesn't have a function here, but it doesn't violate by hitting a line in 2 places at once. Now this was a violation of the vertical line test, because if you have a vertical line, you see it hits in two places. And the same thing would happen if you had that S, like the S that I drew right here, because it fails the vertical line test here, it fails it here, it even fails it 3 times here. And one last little bonus for this, if I had filled in this circle, this would fail the vertical line test because it hits in both places. So the vertical line test is just a visual way to show people, hey, this is not a function. All right, moving on to the second page here. Finding the domain and range of pictures. Now remember, the domain is going to be your x values and the range is going to be your y values. Okay, so the domain is x and the range is y. Now, one way to look at this, when you see a picture like number 30 right here, which I got from the book, this is, I'm going to use a highlighter here to show you that you take a look at the x values, and here are the x values between -4 and 3. So you'll see that this line exists from -4 to 3. And then choosing a different color here, let me choose, let's see, what color do I want? Sorry, doing a new, using some new tools here. You'll notice that this line exists from +4 down to -5. So the green strip represents my range, and the yellow represents my domain. So let's go and write this up here. Writing up the domain and range, the domain would be the values of x such that x is going to be between -4 and 3, and the way that we write that is we use kind of the betweenness notation. And since these are solid dots, we're going to put little equal to signs under there, which tells me that x is between -4 and +3. And we're going to go to the range right now, which is the y value. Y such that, and these lines are just to, separate what we're talking about here, and y tend to go between 4 and -5, so we'll always go from the smallest number to the largest number. And since these were solid dots, we can just put little lines underneath them like so. Alright, let's get the highlighter out, and let's do that for the domain first. Let's go with a yellow. Alright, so we are going to take a look. It looks like my x's are going to go from this dot to this dot, so it's going to be between -4 and +4 there. Okay, so between -4 and +4. And if I went to my y values, my y values go from 5 all the way down to 0 there. This line does not exist below the x-axis, so it goes from -5 to 0. So let's write this up as my formal domain and range. Alright, there we go. So x and x looks like it's going between -4 and +4, and since those are closed circles, let's put little less than or equal to symbols there. And let's do the domain, or sorry, the range. The range looks like y is going to go from 0 to +5. All right. And you'll see that problem number 36, again, if we're, instead of using the colors right now of the I can show you, let's just take this a little quicker. X is going to be between -5 and +2. And since those are closed circles, we use less than or equal to signs. And here y is going to be, looks like the highest level of y is 5, and the lowest level of y is -3. So y is going to go from -3 to +5. There might be little differences in notation going from book to book or person to person, but this is pretty standard right here. All right, let me get rid of this and take a look at some of the problems below. All right, got some more interesting problems right there. Okay, so let's go and do some domain and range looking here. I'll get my highlighter out. Okay. Now, for the x values, you'll notice that it starts here at -4, and the x value goes all the way to the 5. Now, you'll notice in this case, this is an open circle, so it's technically not touching the -4. Now let's go to our range. Our range in this case is not, and I repeat, not continuous. Our range is actually broken here, here, and here. There's actually only 3 values of the range. There's a range value at 2, a range value at 1, and a range value also at -1. So this is a little interesting here. So let's write this up. If we're to write this up here, we're going to have our x value is going to be starting at -4, but you'll notice it's not actually touching the -4, so it's a less than, not a less than or equal to. And it will go all the way to 5 and stop at the 5, but since that's a solid dot, you'll notice that will be less than or equal to. This is just less than, this is less than or equal to. My values for y, much interesting, isn't really continuous. It doesn't go from one spot to another. It just actually exists in 3 places. So the y values, y is going to be equal to 1. Y is going to be also equal to -1. Sorry, I should have put that first there. And y is going to be equal to 2. And it may not be necessary to put down the y equals in each of these. You can just put down y is the field of 1, -1, and 2. So again, you'll see some differences there, but that is really the big trick of this problem, because y isn't, the range is not a swooping set of values. It's just 3 separated segments. All right, now, how is number 40 different than everything else? Well, here's the real weird thing about number 40. This function isn't just what you see on the screen. You see those arrows? Those arrows are going to be rather tricky here, because this line doesn't just start here and end here. It technically exists. If you went bigger and bigger and bigger, it would go all the way across for our domain right there. It doesn't end. And the same thing goes with the y values. The y values would keep going forever and ever and ever. So this answer is really quick to write up, because this is going to be, for our domain, is going to be all our domain is going to be all real. And to do real is just an R with a line through it. So there's my domain. My domain is real, and my range is also real. All right, so you have your real domain, real range, and so since this is a continuous function, it is definitely real for the whole thing. Now, taking a look at problem number 42, you'll notice here that the domain again goes from -infinity to +infinity. This line goes on forever, but our range in this case is just one value, and that's the value right there at 2. -2, I should say. So if we have to write up our little value right there, we have x is real, and we have y such that y is equal to 2. So you can put a 2 here if you like. You can go to y equal to 2. It feels good to do that. Now, looking at problem number 44. Problem number 44, the domain is going to be all real, because it's going to this frown will continue on to infinity, but the range, the y values, do not go into infinity, at least in the positive sense. The range basically starts at this +4, and this frown goes negatively to -infinity on the range. So this brings a more creative inequality writing system. So our domain is going to be x such that, let's see, x is x is all real. Sorry about that. And then the y value, and the y values for the range is going to be anything 4 or less, and including 4, since that's a solid dot right there. So y is going to be less than or equal to +4. All right, and this chapter is definitely going to give you a workout, so please, send me questions if you have it. But before we finish, we got one more section to do, and that's going to go away, and let's focus on the right-hand side of the worksheet here. Find the function of values. Now see, what we're going to do here is just plug these into the equation to figure out what they are. And these are relatively quick and easy problems. There's some tricky stuff when you get to some of the later letters here, like you get to E and F. So there we go. Now I've centered that nicely. Okay, so the first part. Now you might be confused as what is this g of x? This is just function notation. This is just like saying y equals, or the function of, this is the function g of x, or you can consider this a y. But this is really, when we deal with more than one function, we might give them letters like g of x, h of x, and that way you can tell them apart instead of y sub 1, y sub 2. So this is g sub 4, so what I'm going to do is plug 4 into my equation here. So this is going to be 5 times 4 minus 1, 20 minus 1, 19. And this is just straight substitution. G of 8 is plugging 8 in for the x, so this is 5 times 8 minus 1. You go 40 minus 1, and that's going to be equal to 39. Negative 3, plugging that in for x, so this is equal to 5 times negative 3. Whoa, negative 13. Where'd that come from? I wish I had a better erase function. Sorry. 5 times negative 3 minus 1. This is negative 15 minus 1, and so the answer is negative 16. See how this works? Just pretty simple. 5 times negative 4 minus 1. This is negative 20 minus 1, which is negative 21. Now the real fun begins is when we deal with E and F, and I'm going to erase this here just to give myself a little bit more room, and it brings that down there. Alright, so here we go. Alright, a minus 1. So how do we do this? We're going to then plug a minus 1 into each of these problems right here, and that's going to get kind of interesting, because g of a minus 1 is taking the 5 and then replacing the x with a minus 1. Minus 1. So what happens is you have to do a little bit of algebra. 5a minus 5 minus 1, and therefore I've got 5a minus 6. So g of a minus 1 is 5a minus 6. Now this one's interesting because what I'm going to do is take my a and plug it in for my x. So this is going to be my function 5 of a minus 1, and then I'm going to put a plus 3 after the function. So really this function is right there, and the plus 3 gets put on at the end. So this just becomes 5a minus 1 plus 3, or 5a plus 2. So there it is. There is your composite function. That is a function where we've plugged a into where x was, and then we put the plus 3 at the end of it. Alright, we've got one more example to go. Alright, let's see what we got for space-wise here. Alright, so here we have some exponents to cause a little bit of stress on your life, but shouldn't be too bad. So, plugging 0 into my equation. So I've got h equals h of 0, or h of 0. We plug 0 in for the x, so we have 3 times 0 squared minus 2 times 0. Well, that's going to be 0. That's pretty straightforward. Now we're going to plug in a negative, so 3 times negative 1 squared minus 2 times negative 1 equals, now this is where your algebra skills come in handy. Negative 1 raised to the second power is 1, so this is 3, if I simplify that there. And this is negative 2 times negative 1, which is technically going to then be positive 2. So my answer here is 5. Now if I plug 3 in this here, I'm going to have 3 times the quantity of 3 squared minus 2 times the quantity of 3. So that's 3 times 9 minus 6. So 27 minus 6 is 23. Now the letter t, just plugging that in, you're going to love this one. 3t squared minus 2t. Yeah, that's it. That's it. Just plugging the letter T in for the letter X. That's the only change. Okay, I found an edit. Or edit. Okay, what I'm going to do for this one is plug in 2a into my equation. So this becomes 3 2a quantity squared minus 2 times 2a. Now this here becomes 3 times 4a squared minus 4a, and then that will give me 12a squared minus 4a. So the 2a was plugged back into my original problem here, and as I squared it, I got 4a. Now, in my final example here, I'm going to plug this this 3 for my function h into the problem and then subtract 4 from it. So in my equation, I'm going to go 3 squared minus 2, 3, and then at the end of the equation, I'll put a minus 4, since this square bracket right here really tends to this piece. So this is going to be 3 times 9 minus 6 minus 4, or 27 minus 6 minus 4, which is going to be 17. All right, if you have any questions, send me an email. Just let me know.